Hey, so today I decided instead of doing a guitar demo, we're going to just talk about guitar wiring a bit because some people have asked about this on my channel more than a few times over the years. This is not meant to be like a definitive massive guide for the most part. This is meant to be just a tutorial in a way to kind of teach you how guitar wiring kind of works from a very basic perspective that most people can grasp. I'm going to be doing almost all this in DIY Layout Creator. Now we're going to start here by talking about pickups. So in the world of electric guitar, regardless of the form factor, aka the design of the pickup, we have two kinds of pickups on an electric guitar. We have what's called a single coil, which is just a coil of wire wrapped around these magnetized pull pieces here in the typical design. Sometimes they may have a magnet on the bottom to magnetize them. So basically all a pickup is a coil of wire around a magnet. And the amount of wire wrapped around, the wire is hair thin, and it's basically wrapped around the magnet over 3,000, 4,000, 5,000 times. And then the second one, is your humbucker. These share a single magnet in here and have two coils wound reverse phase, reverse polarity with each other. And what these do is these effectively cancel out that 60 cycle hum noise that you used to hear if, say, you were near something high voltage like a television or a television camera or a power transformer or something. You'd hear that little buzzing noise from your guitar. These are meant to get rid of that. So these are the basic building blocks of almost any modern solid body or hollow body electric guitar, basically, are these two pickups. When we talk about outputs on them, well, your typical single coil just has two leads. Let's go zoom in. So your typical single coil has two leads, a hot lead and a ground lead. And it really kind of doesn't matter. It'll work in either direction, but it does matter when you get into using multiple pickups because that'll be determine the way the guitar sounds when pickups are combined. And if not done correctly, you might have a loss of output and get that out of phase sound with it, which isn't necessarily a bad thing. It's actually a good thing, and it's quite useful. The next type of pickup here, humbucker, we have two types. We have one where, to tell you what type of connectivity we have here, we have what's called the series link, which are the link between these two coils right here is performed there. And then your output, your input and output, or your your positive and negative leads here are these two outer lugs here in DIY Layout Creator. A two-conductor, humbuckers were originally two-conductor pickups just like single coils. You just had a ground wire and a hot lead, and you plugged them in. Almost all the original Seth Lover designed basic Gibson designs, including also Fender's wide-range humbucker, were all done the same way. You had one, just a positive and negative lead. But sometime during the 70s, I'm guessing, some guy got really, really, really clever and thought, hey, we could take the series link and delete it, and we could do a whole bunch of cool stuff with these two leads, which means you could run the coils in parallel. You could run the coils, you could ground this section off and make this a single coil or a coil split, as it's commonly called. So there's a lot of cool stuff you can do with humbuckers, but because due to that added complexity, we're going to start with just the basic single coil circuit. There's one other component needed, though. How are we going to get the output to the amplifier? Well, we're going to go ahead and use our 1/4-inch output jack here. And your basic guitar circuit is just these two. Now, on your output jack here, and I got to find a cable to kind of show you this. Let me go see down here, and we'll go back on camera, and we'll kind of take a brief gander at this on camera. So I'm going to go ahead and scroll up here. So now we're back on camera. Let's turn that on. Right here we have my iRig, and right here we have your typical cheapo guitar plug. This is called the tip up here, and this is called the sleeve. The sleeve is your ground. The tip is your hot lead. This is where the sound comes through. So anything having to do with sound modification and all that comes out to this. And then say this end goes to your guitar, and this end goes to your amp. Signal goes through this, goes through your cable, and comes out through this side into the amplifier. And that's how those jacks work. So let's go back to the desktop scene here. So this would be that long, thick part called the sleeve. It's marked with an S here in DIY Layout Creator. And that's your ground. The tip, of course, here is your hot lead. So what we're going to want to do is to start out with, for connectivity, we're just going to use green as our basic hot lead. And take that, and then we're going to drag it all the way over here to our tip. And then we're going to just drag this one all the way over to the sleeve, and we'll change its color to white, so then we at least know it's a ground wire and not the same thing. And then one last piece we need to make. And then we're going to pick a schematic symbol here, which I'm not going to do a full thing on schematics, but this is kind of how it works. We have our ground right here. And I'll double click on it and change its color to white. So this is your ground wire. And where this goes, so I'll show you on a working electric guitar here that I actually have. So we'll go back to my Garage Talk Guitar Tech. Here we have my Kramer Striker 100 ST. If you look back here, this yellow wire going to the tremolo claw here, that's your ground wire right there. That yellow wire that's soldered right there to that tremolo claw, that's your ground wire. And then that runs back into here and connects to, in this case, it connects to the volume control on the guitar. And we're going to talk about grounding a little more once we go past this basic tutorial on electric guitar wiring. So this is a basic circuit that will indeed work. You could go out, buy a cheap single coil pickup and an output jack. This kind of circuit I've seen used. Actually, my guitar teacher in high school, Mr. Orr, he actually used this circuit on a acoustic we had made by Seagull that had like a Gibson, I think it was a Gibson T-top pickup that was in it, in the neck. And so we used that to electrify the acoustic guitar. This was also the same kind of circuit that Kurt Cobain had in his Martin D18E they used on Unplugged. That was just a Bartolini 3AV single coil run into an output jack. I don't even think he used a volume knob on it. And yeah, there's a common circuit on electrified acoustic guitars. So we're going to kind of zoom out now, and we're going to take a further look at this circuit. So there's not a whole lot you can really do with this circuit. I mean, you can't control your gain, you can't control your volume. You're stuck with what you've got out in the middle of the amplifier here. Let's delete whatever the heck that was. And then, so there's ways of controlling the volume and tone of your electric guitar using, there's a way of controlling your guitar's output. So let's rearrange this circuit so I can kind of show you the building blocks of a basic circuit a little more. So we're going to move our output jack all the way down here now. And we're going to focus on dragging this all the way down here. Let's take this wire here. We're going to be expanding that wire in a minute, so we'll just leave it like that. So there's our basic circuit. And then we just drag this over here. Maybe we need to make some room on the other side for some things later. So we're just going to do all this. Yes, I could have probably done all this premeditated, but come on, I like the old school YouTube, let's do this live vibe. Mistakes and all. So, basic circuit, well, now we're going to add another piece to the piece to the pie. We go under passives, and we're going to take a look at this item right here called a potentiometer. So a pot, and disregard all this here if you know what all this means, so I wonder why you're watching this. Anyway, so you have 3 lugs here that you solder to. These 2 go in a little horseshoe covered in a resistive material called the resistive track. And then this one goes to a movable wiper contact, kind of like a windshield wiper that moves along that resistant track. And then let's set our values for this pot. So I'm just going to pick a nice middle of the road value, 500K. They're measured in ohms, which is this symbol right here. And most guitar pots are kilo ohms pots. You sometimes have a pot that's like the 1 meg pot. You'll find those in your Fender Jaguar, Fender Jazzmaster, some of the other Fender models. I think the wide range humbucker guitars have them as well. You have 500K, which is used with Gibson guitars with humbuckers, typically. 250K, which is typically used in your Telecaster, Stratocaster, Mustang, Jagstang, what have you. And then down here, 25K, which is most often used with your active pickups, you know, your EMGs, your Seymour Duncan Blackouts, your Guitar Fetish Red Actives, that type of stuff. Right now, we're going to just use 500K, and on top of that value, you also want to pay attention to the taper. So the human ear does not perceive sound in a linear format, which means the more you turn it, it just goes straight up. The human ear will perceive a linear pot like that in a standard wiring setup as not being, as just being all of a sudden it's suddenly off. So we have what's called logarithmic pots. Logarithmic pots, aka audio pots, they're usually marked like 500Ka or 250Ka or 1MA. Though some linear pots are used, the Jaguar and Jazzmaster are another example of guitars that have linear pots in them. Logarithmic pots are typically what we use for most applications, though. There's also a reverse logarithmic for people who are left-handed because the taper is not symmetrical on a linear pot. It has to be, the resistive track has to be calibrated in a certain way where it falls at a certain rate at a certain part of position so that it actually works. So we're going to pick just logarithmic here, assume it's just like a right-handed guitar, and we're going to mark this control. Its name is going to be, instead of VR1, we're just going to call it volume. And there's our volume pot right there. Well, how do we connect it to this pickup? Well, here's what we're going to do. We're going to change quite a few things here. So instead, first off, this ground lug is going to go, well, actually, no. I think we're going to start by just explaining the most basic way it could work, which is we take our hot lead from the pickup here, and then we're going to change the color on this for future reference to yellow now. Okay. And then we're going to scoot that wire over here. And then we're going to take another connectivity hookup wire, and then we're going to take another one here, and we're going to run this down to the volume, to the output lug, aka the tip of the output jack, right over here, and make some room maybe for another tone control later on. So this basic circuit, as it is, will work. I mean, you'll do that. You definitely are going to have control over the volume here, but it's not going to be able to turn it completely off, which, if you're playing on stage at high volume, you're going to want. Instead, what will happen is you'll just end with really, really low volume or really, really low gain at a very high volume using this pot. This is where we're going to start our discussion on how to ground a little bit properly. So this circuit would work, but say you're on stage. Now, there's multiple schools of volume here. The modern guitar player usually has a multi-channel amp with a clean channel, a distortion channel, a clean channel and a distortion channel at least. But if we roll back into the past of electric guitar and people who just want to use a traditional rig, something like Les Paul into a Marshall or Eddie Van Halen, he was playing very much a similar schematic to this, run into a Marshall Plexi Super Lead with all the knobs on 10. That's what gave him his crunchy tone. Edward Van Halen would control his volume control his distortion by rolling the volume control back. And when he did that, it would lower the output being sent to the amplifier, and then you'd clean up the sound, and then he'd also pick lighter so he's overdriving the amp less. With this setup, unfortunately, what will happen is if you roll it back, you're not going to get enough reduction of volume where you're still on stage, and it's still going to be pretty freaking loud if your amp's being overdriven and distorted. And you want a full off experience. Well, we're going to start here by dragging this lead over here, and then this lead over here to the pot casing. If you've ever looked inside of an electric guitar, and we might take a look at that Kramer in a minute to kind of show you the real life example of what I'm posting here. We'll make this dark, sort of a dark grayer color, because typically when we do this, we're creating a grounding bus now. So all the grounds are going to go to the volume control pot. And that's the most common way it's done on most standard Strat, Tele, Les Paul, Mustang, etc. type guitars, especially those where there's only 2 knobs. And so we're going to move the links for ground over here. So there's our neck pickup, or our single pickup going in ground, and our hot lead going into the pot here. This is our output from the wiper contact, and then this is the ground that's going to go to our bridge, which I'm just going to go ahead and drag off to the side here for a minute so we can kind of do that. So I'm going to rearrange my wiring a little bit here. So here's our standard electric guitar grounding thing, except one thing we forgot. We need another hookup wire to go down here for our ground wire, for our grounding bus. And then we're going to change the color of that to white. And there we go. So now we have a second circuit. And how this circuit works, the output of the guitar goes through this. It goes through the pot. Depending on the position of the wiper contact in here, it might go up and through here and all the way there. Or it might just go leap right on over here to our output jack. So now you can control the volume on your guitar. And this ground wire makes sure, and this is where we're going to talk about a major part of electronics that you need to understand really early, is that electricity takes the path of least resistance. And so that's how potentiometers work. So when you have this going this way, more electricity is going to go to the output jack the closer the wiper contact is to this side. Whereas closer to this side, it's going to start sending more and more frequencies off the ground. That's also why on some guitars we connect a capacitor between these two. Usually a low value ceramic or whatever. And this is what we call a treble bypass cap. And what this does is when you've rolled the volume control past like 50% or even 20% on a logarithmic pot, it still allows higher frequencies to pass through here at full frequency range. So as you're rolling it down before it just grounds off completely, you're still getting your high frequencies. Does that make sense? And that's why we have that there. And that's a common practice on electric guitars nowadays, because if you're using an old school amp like a Marshall or a Hiwatt or, some vintage amp from the 70s or 60s or 50s, and you're using overdrive by cranking the shit out of it, then yeah, you might want one of those to retain that clarity and depth when you turn the volume down. But not all guitars need that. I mean, you can have that capacitor there, you can choose not to. It's going to make a difference in sound. And this is basically the same circuit that's inside of my Kramer over here. So we're going to jump back to the other view in a minute, and I'll open the back and kind of show you. So right now we're back in the back of my Kramer Striker 100 ST here, which has a very similar wiring diagram to this. So I'm going to try to catch this in a way that you can see it right here. So we're going to scoot this out of the way, get you a little better lighting here so you can catch a glimpse on this control cavity here. So what we've got back here in this Kramer, right there is your volume potentiometer right here. This is a 500K logarithmic audio pot which if I bring the Kramer up closer, you might see even better. So there's our, well, my pointer is going away. So right here is your 500K ohm. Dang it, I gotta pull this back. So right here's your 500K ohm logarithmic pot. That black wire right there, that's your hot lead. Output is in the middle and it's grounded out here. And this is our grounding bus right here, this one central spot. Everything is going there. And then this all goes to this output jack right here on the side like that. So that's how this diagram will look in real life. And I'm going to try to get you even closer to it so you can see even better. So you can see I have kind of a grounding bus right there created right on the corner of the pot. I just chose to use a lug and just ground it off. And then as you can see, the white and black are the hot and ground going to the output jack. And then that red wire going in, that red wire going in, that is my humbucker pickup, my this humbucker or Samick humbucker in the back of this Kramer. And that's like your basic wiring diagram. As you see, it's exactly the same thing as we put there. The yellow wire is my ground going to my bridge like I showed earlier. And if we get up, let's get up even closer. And hopefully we don't lose focus. White's my output, black's my ground. The red and gray are from the pickup. I had to put excessive leads on it. As you can see, the gray goes to the ground lug on the far right side of the pot, and the red goes to the input lug. So there's a real world example of what the inside of an electric guitar's wiring cavity looks like. And you got your pot, you got your switch down here, you got your ground wire going to the claw, and then of course, obviously in the front of the guitar, we have your humbucker pickup right here, which is the gray and red wires. And basically, that's what you do with this setup. You know, I'm playing this through a cranked Marshall, maybe like a JCM 800 or a Plexi or a JMP 45. You just turn the volume down just a little bit to clean up the tone. If it's all the way down, it's all the way off. And all the way up is all the way on. Pretty basic stuff. And that's how a basic single pickup circuit like that works. Now let's jump back to my desktop and we'll start talking about more features that we can add to these electric guitar circuits to make them effective. So now we're going to kind of jump into talking about two pickup guitars. We're actually going to first talk about one other main thing. So a lot of guitars have a single potentiometer, have two potentiometers. You might be thinking, oh, what's that second knob do? So we're going to create another 500K logarithmic pot here. And this is going to be close to the same kind of circuit you'd find in a Gibson Les Paul Jr. Oh yeah, and we're going to change the name of this to tone control. This is our tone pot. And there's a couple different ways you can connect a tone pot. There's the Gibson method, which would be something like this, where we connect a capacitor or a wire to the center lug from the output jack, or is the Fender way, which would be this way, or we just take a capacitor here and we put the capacitor here on the side. Let's say for this one it'd be 0.47, and then we put it as UF, because that's what I usually see on a lot of those schematics, though I could be wrong. I'm working completely off the cuff here, no script. And then we're going to create a hookup wire here. We're going to create a hot pink one that just goes here. And we're going to wire this up Fender style because I'm going to be doing a lot of Fender schematic type stuff here. And so we're going to make this hot pink so it's very visible. There you go. So now this is your tone control. And then we need to add one more hookup wire between here and there as a part of our grounding bus. And this will go there. Now, I must make a disclaimer as we get further into this. These diagrams are going to get less and less in line with actual production instruments and kept kind of simple like this, just so people can figure out what, what's really going on inside the guitar. We might jump into more advanced schematics eventually and kind of show you maybe how certain smaller elements affect tone, but for right now, this is effectively the most basic, most widely used tone control ever. As you can see, we've started putting all our grounds on the volume pot. You want them all to connect out to that one spot. It seems to reduce noise and it seems to have a better sound in my ears. So you want all the grounds to go to that one central spot. And that's how I've done it, and it also makes it easier to modularly remove these parts. So say if I later wanted to remove the tone control, maybe put a phase switch or a coil split there instead, not muck up the guitar. Say I had like a vintage Kramer Pacer Deluxe or something, and I didn't want the tone control, but I wanted to split my pickups, I could just take that tone control out and put a mini toggle there and just unwire the original parts, and then it would, flip-flop it over. That's why I like these a modular view to wiring a guitar. So now what happens is when this pickup goes in here, the signal is also going off this way, and it's being grounded off through this capacitor. This is what we call a low-pass filter. And what it does is it basically sends all the highs off the ground. This is a basic tenet that I'm going to talk about later. When we get to things like the Fender Jaguar. The Fender Jaguar has an extra switch on it called a strangle switch. It works the reverse of a tone control. Instead, you're passing the sound through the capacitor to the other side on a strangle switch, or even that treble bypass mod I showed you a few minutes ago. Whereas here, we're grounding it off to send all the highs to ground. And the schematic, that's what it does. So like if you went ahead and turned this pot all the way up, it's actually disconnecting it from the circuit. So say you turn the knob, wiper contacts all the way in the up position, it's all the way over here connected to this lug. And since electricity takes the path of least resistance, only a very minuscule amount of current is going to make it through that capacitor on this side. That's where we're going to talk about why you might or might not want a tone control. I like tone controls in my guitars with single coil pickups because it takes some of the edge off the pickup even when it's not in use, because you're still losing some highs through the pot depending on the pot value. The higher the value, the more highs are there. That's why your Jazzmaster sounds ice picky, but if you put those Jazzmaster pickups in another guitar with 250Ks, it would sound super thick and very, very warm, maybe too much so. So this also helps in getting rid of some of the high frequencies by having a tone control on there. Even as little as I use my tone controls, I like having them on certain guitars of mine because it gets rid of those high frequencies to ground even when it's completely wide open, because this is still a connected circuit. So it's a useful part, but there are production guitars that use this type of circuit. One of the examples would be the Gibson Les Paul Jr. It's a single coil P90 pickup over here. Just to show you what a P90 is. It's basically just a bigger single coil that's wound hotter. That's all a P90 is. It's the same thing as this. Thousands of winds of hair-thin wire around magnetized pole pieces or a magnet inside of just a larger package. That's it. And a Jazzmaster pickup is also the same sort of deal. Actually, you'll find when I do schematics in here, I just use the P90 for my Jazzmaster pickup marking. So you have the single coil pickup here, and it just outputs the volume control, and it has a tone control to cut off some of the treble frequencies. Maybe you want warmer frequencies, and that's about it. And then sends it all out to the output jack and sends it to your amplifier. Another guitar that uses this setup is the Fender Musicmaster, the Fender Swinger, Musiclander, and the Fender Bronco, which has almost an identical diagram to this. You have one pickup, usually in neck position. In the case of the Bronco, it's the bridge. It just sends to the pot. This cuts off some of the highs even when it's off, which helps tame those single coil sound. And then this just sends the output to the output jack. Same same freaking thing. It all just follows this path through these wires that are a different color than white to actually do all the cool stuff. It's just your grounding bus. So now we're going to add another pickup to the equation. Let's add another single coil. So now we have another single coil pickup. We're going to just for ease of viewability, we're going to do this. We're going to pick this pickup, and then we're going to do Alt, and then we're going to turn it around this way. Typically, they're all in one direction, but I figured it'd be kind of fun to do it this way because we're going to lead into some 2-pickup guitar schematics. So now we have 2 pickups. Let's go ahead and connect one wire here on this side, another wire, and we're going to make this one blue. This one's going to be blue. And then we got another white wire coming from here too. So we're going to take that. We're just going to copy and paste that. We'll put that on here. And then we'll just drag this over here to the grounding bus. Now we have another circuit identical to another production guitar that we know of, the Harmony H804. The Harmony H804 was a student electric guitar introduced by Harmony in 1987 as like a cost-reduced version used to minimize, I'm supposing also to minimize needing the special big chrome single coils that the H802 had. So they used Strat pickups instead. So here you had 2 Strat pickups wired directly into a volume pot and then into a tone pot. And just like the single pickup circuit, it just all went to the output jack. You had no way of changing the tone or combining pickups or isolating pickups. So how would we isolate pickups? Well, we're going to talk about a few different ways this is done. There's a few different switches, and we're going to just stick to the popular options right now because that makes this tutorial a lot easier. The first method here, we would take this hot lead here and this hot lead here from each pickup, and we put them to each side. This is a Gibson style wafer switch. This is what it looks like on the bottom. If I am to show you what this looks like in real life, you're probably, and I'm going to grab another example guitar of this from my rack above me. We have my BC Rich Warlock right here. And this is the Gibson style toggle. We're showing the bottom of this. There are versions where there's just like 3 lugs there, but I'm going to talk a little more about it. But yeah, this is the type of toggle switch we are talking about here on solid body electric guitars. So let's get back to the wiring of this type of switch. So underneath here we have, this is called a leaf switch. So each of these pairs of contacts are what we call leafs. And what they do is when you tilt the switch this way, the other side of the switch tilts this way and breaks the contact between these two connectors here. And if you tilt it the other way, it breaks the contact between these two. It's all about breaking and making contacts within the switch that allows you to actually put pickups together. But without this lug connected, this is utterly worthless. So right now what we're going to do is we're going to grab another hookup wire, and we're going to drag it over here. We're going to just keep this one green. And this is going to be our hot lead. And what this does is then if this pickup's in the middle position and both leads are connected, this pickup will go in here, this one will go in here, and they're put together through these 2 lugs soldered together in the middle and then sent to the output jack. But if we tilt it one way or the other, we either get our neck pickup or we get our bridge pickup. And this is the most common wiring scheme in electric guitar today with 2 pickups. I mean, pretty much this applies to just about everything. Your dual humbucker Schecter, your dual humbucker single volume, single tone control Gibson type guitars. Maybe somebody had a modified Les Paul Special and threw another pickup in the neck. This is how the original Fender Duo Sonic works. Of course, there's also a ground wire that goes to the top up here and goes to your grounding bus. This isn't always used, but that's what that top connector is for, just to show you. But you don't really need this. I mean, you're perfectly fine without it. It's just a best practice to actually use that. But for right now, for the basics of simplicity and making it easy to see how these circuits actually work in a working scenario with a working electric guitar, yes, this is how this works. So now we got this toggle switch. You can flip-flop it back and forth, and you can make and break the contacts. Well, there's another popular type of switch here called the wafer switch, or the Fender style lever switch, which looks like this underneath. These two red contacts are your common contacts that connect together. So these two red contacts are always on. This is position 1, this is position 2, and this is position 3. This is position 1, this is position 2, and this is position 3. So on this switch, how we would wire it is we would take, say, your bridge pickup, we'd wire it over here, and we take your yellow here from the neck pickup, and we'd wire it over to this red one. And this is going to be a little hard to make clear here, just so you know, because, you know, the confines. And then this is going to go over here to this lug, which is going to be joined together between multiple lugs. So I'll show you how that's done. Connectivity, we just take a hookup wire, we run it down here like that. Just pretend these are all kind of connected, because I'm trying to do this as quickly as possible. So you just have this wire right here, and it connects this one and this one together, and then ties this one and this one together. So when you're in the middle position, this pickup and this pickup are being sent to this green wire right here and sent there. But if you're only up in this position, this pickup gets sent to this wire. Voodoo-voom, voodoo-voom. You got neck pickup. Flip it the other way, bridge pickup. Now, I could go on even further about the original broadcasters and Esquires and how they were wired, and the Esquire being a single pickup guitar and having a toggle. But we're not going to go into that. We would probably want to do like a specialized Telecaster episode to talk about that. So those are the two most common ways these are done, and they're actually quite complex compared to the simple way it's done. So let's say you have, let's talk about toggle switches. Let's talk about other types of switches, your slide switches. God damn it. So where do we find this? Electromechanical. So now we're going to take a slide switch. We're going to put one here. We're going to turn it horizontal. We're going to make it single pull, single throw. And then we're going to go ahead and show bracket. So we're going to take two of these. This is what the Harmony H802 was wired like. You have your neck pickup going into this one, and then your bridge pickup goes into this one. And then you have these two, and slide switches are the best way to show you how switches actually work. So because they actually work in a way that's pretty logical. It's not like you flip the switch one way, but the contact inside goes the other. So here you go, a basic slide switch. And this also applies to another guitar, and the reason why I flipped this pickup over. This applies to another guitar that they made. The Fender Mustang in particular had some special switching added to this, but we'll talk about that one in a moment. So the way the H802 worked was, even though it might have looked different, you had the neck pickup going to one switch, the bridge pickup going to the other, and then the switch's middle lugs were tied together and tied to this wire that goes to this output jack right over here. And the way this worked is that neck pickup goes in here. If you slid the switch this direction towards the pickup, in this case, as you can see, this would connect these two, and then you have your neck pickup. If you slid this one this way while that one's on, you get the bridge pickup along with it. And if you turn this one off, you just get bridge. And well, the reason why for the other two schemes for switching The reason why those exist the way they do is because this is not a very convenient way to do switching on your guitar. And some Fender Mustang clones do it this way too. I know the Fresher FM5T was one of them, as well as the Fresher Mercury, which were like cheap Mustang clones from the 70s. So they just had this, and you just had in phase. So now we're going to go to something more in line with the actual Fender Mustang, which will be familiar to you folks. So this is a good time to do it because the layout's this way. It's a little more complicated, but we'll get into it. So the Fender Mustang has two three-way switches like this. Three-way slide switches. And this is one pole and this is two pole. This is called double pole, triple throw. So in the up position, these two are linked together and these two are linked together. In the middle, these two are linked together and these two are linked together. And then down, these two are linked together and these two are linked together. So if I drag this over here, this is typically the way your Fender Mustang type guitar is going to be wired. And hopefully I'm making this clear enough at explaining stuff. So we're going to take the hot leads, we're going to put them on each of these right here. And this is going to be our hot lead. Now we're going to disconnect the ground from each one of these, and we're going to put it on here. So now we have this, and then we're going to take this wire here, and we're going to do the same exact thing for the bridge pickup. So now what we're going to do is we're going to take this and drag it over here, and delete that wire, and we're going to drag this down over here. And then what we're going to do is we're going to do I probably could have done this a lot faster if I just wired up the switch. We have this one going here. And then we're going to copy that one and copy V. And then we're going to put the same one down here. And then we got another hookup wire that's going to go over here. And we're going to do that one white. Actually, we might do this one black because it'll be more visible there. But we'll see here. So now we want to keep clear of that connection. Yeah, let's go ahead and try white and see how that looks. There we go. That makes enough sense for people. And we'll take this one here. Now, I'm not following any specific color codes. So now, if we leave this as is, yes, if we go up in this up position, the pickups are going to work and they're going to be reverse phase. So we need to do one last thing here. We need to link these over, which is typically done with a silver wire, not much unlike the one that we bare silver wire, not much unlike the ground link on the volume control. So we'll change that color to gray over here. Copy. And then we'll put another one there, another one here, and another one there. And so here you have a Fender Mustang, or Fender Duosonic 2, as we would put it. Each pickup goes in each lug, and then what these lugs do, oh, we forgot one major piece. We need to hook the hookup wire. We need to make sure we link these together so that it works. That's the one thing I forgot to do, is link our wires together. So we're going to change that one to white. And then after that, we also need another white ground wire here to go to the pot potentiometer for the go to our grounding bus. So what we'll do here is we'll take this one, and then this one goes here, and then it goes kind of under there like that, and then under there like that. And hopefully we can kind of get each get this a little more clean. They're done. There we go. So now we have basically a Fender Mustang or a Duosonic, depending on whether you have a tremolo or not. 2 single coil pickups, each one goes into its own switch. And then you have a volume control and a tone control and the output jack. There you go. How these work is they do what's called phase reversal. And how this is done is you have this toggle, this slide switch here. If you slide it up, everything's out of phase because it links this ground wire to this hot lead and this hot lead to this ground wire. Whereas if you slide the switch down here, it links this ground wire to the ground wire, and it links the hot lead to this green hot wire. And it just sends it through this matrix all the way out into the output jack. Reverse phase, reverse polarity, reverse phase on pickups, what it does to them, it gives them that honky, mid-rangey kind of sound. Think Peter Green from Fleetwood Mac. Think a lot of 70s guys used that sound. So the Mustang was really like the first production guitar to have that feature. And that's how the switches are wired. But again, as we're saying, this is completely asinine because it's hard to do live switching. So now we're going to talk about a CreepingNet exclusive method of doing this. So let's disconnect these wires here just briefly. Actually, we're going to disconnect this one completely. And then let's disconnect everything from this bottom switch. I'm going to show you how my Jagstang is wired. So we're going to take this one here. This wire is going to instead go up to one switch in the neck position. Or actually, this is how my Musicmaster is wired. The Jagstang is a little more complex than that. And then this wire is going to just go up here too. Yeah, I know. A lot of wires floating around right now. This is like a passive version of what's in my Jagstang. So right now we're going to take this top one here and we're going to drag that down there. And then we're going to take this one here, drag this across. And we're going to copy that, and we're going to do one more that goes this way. And we're going to take our bridge pickup lead here, and we're going to drag this there. Take our hot lead here, drag that to the middle. And we're going to take our neck position pickup here. We're going to take this hot lead from the neck position, and we're just going to drag that into this one. What we've done is we've turned this three-way switch now. Instead of having phase reversal on both pickups, we just left it on the neck pickup. And the reason why I chose to do that is because the difference between the in phase and out of phase on each pickup is so negotiable that most people are not going to hear the difference. They're not going to hear the subtle difference. So I just usually opt to just do out of phase on my neck pickup for that reason. So now instead this switch stays the same, which adds a secondary cool feature. First off, let's explain how the pickup selector works. So this is your middle output wire that goes to the pot. And if I keep the switch in the middle here, this wire here links up to that, and this wire links up to that, and these two are linked together the whole time. This acts as like the same joining of the leaves on a Gibson style switch. So when you're in the middle position, you got both pickups. If you're up here, you just have the neck, and if you're down here, you just have the bridge getting output. It's all about making and breaking contacts, but the phase for the neck pickup is controlled by this switch, and this gives me it takes away the setting of having the bridge pickup off for the most part, or at least both pickups off, but it does give me an off position, so that if I slide the switch really fast, I can do that whole chopping a sound like you do on a Gibson guitar. By turning the volume all the way down on one pickup and then just moving the switch really fast by putting this in the middle position and turning this pickup off, and then just bridge in these two positions and then off up here, and I just go bloop, 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 and I can chop the sound up. Another thing is it gives me the in phase and out of phase sounds with the neck pickup when joined with the bridge pickup, which gets rid of the redundant settings and gives me a faster, easier way to access those settings in a live scenario where I need to switch. So I'm kind of showing you my logic and how that works when I come up with these circuits. So now that we've seen what the Mustang circuit looks like, let's talk a little bit about the Stratocaster. And in order to do that, we need to delete some things. We need to take another pot here. So we're going to do this. So now we need a second tone control. We can take this pickup and let's see here. We're just going to Alt and then rotate it like that. Copy it. Put this in the middle position. And then we're going to delete all of this over here. And then we're going to take this wire, and this is going to go here. Take this wire here. And now we're going to add another wire to the middle over here. And then we're going to drag this wire up over here. So now we're going to talk about the 3 pickup Stratocaster circuit. Now we could, in effect here just put all these on toggle switches. But like I said, well, it would give us the full combination of pickups. It would eliminate the ability to, it would eliminate the fast switching we need live. We're going to make this one over here. We're going to make this one orange. So we're going to go here, orange, there we go. And then what I'm going to do is I'm going to take a couple white wires here. And we're going to focus mainly on the switch here at first. So I'm going to take this white wire. This one's going to go here. This one's going to go here too. And then this one is going to do the same, and we're going to take it up here. We're getting into basically Stratocaster territory now. So that wire is going to go over there. So there we have our grounding bus completed already. Now we're going to talk about the switch. Now I know a Strat switch would be over here, but for clarity we're going to do it over on this side because it's easier to see. So we're going to go to guitar, we're going to go to lever switch, we're going to put this here. Now, when we did the Telecaster style wiring, we connected these 2 lugs to these 2 lugs, and then that was our output. On this, we're going to do it a little differently. Instead, here, what we're going to do is we're going to drag this wire right over here, and then we're going to drag the switch over here. Then instead, each pickup goes on each lug here. So neck, our yellow wire, is going to go over here. Our orange wire is going to go on that middle lug down there. And the blue is going to go down here for bridge, and we're going to drag that wire over there for visibility. And I'm probably going to drag this down a little too so it's not running over the top of our pickup. So right now we have a way of switching between these 3 pickups. We could, of course, in effect, just link up a single tone control right here to the volume control. But that's not how a Stratocaster is typically wired. Typically for a Stratocaster, you have 2 tone controls. You have one that goes to the neck pickup and one that goes to the middle pickup, and the bridge is wide open. The first piece of this puzzle is we need to link our connectivity together with this hookup wire for each pole, so we'd have this wire here that just joins these 2 red leads together, and then we take this wire. So there we go. Now we have our green wire right there. And so now this one's the one that's active for the tone control over here. So now this is going to be our new purple wire that's going to go over here. Ah, shit. I got to grab that a little better. So now that goes to the tone control. And we're going to change it to purple. So that's our neck position, tone control wiring. And that's going to wire our tone control in when the neck pickup's on. And we have a second wire that's going to go to this middle lug, and that's going to go over here. And then we're going to kind of bring it down there, and then we're going to kind of lift this one up over here. And then this would be maybe for another bright color. Maybe we'll pick turquoise for that one. So now we have, that's your middle pickup tone control, and that's your neck pickup tone control. And there you go. It's basically your Stratocaster circuit. So when this is linked up and this one is on, you know, let's do a sanity check too, because these wafer switches, are a little, you know, iffy as far as me getting them right. So this is a classic 60 style wafer switch. It's actually wired in reverse from where I did it, but so I did it correctly. So there you go. So that'd be your wafer switch. You'd probably flip it over the other way, but this is just one way to get it to work. One thing I must tell you, a trick when wiring guitars is these switches, if you get them completely backwards, you don't have to rewire them. You just flip it over and then screw it in, and it'll work in the opposite direction like it's supposed to. That's a little trick, a little handy quality of life trick when you're first starting out and learning wiring these. So yeah, what this does is this links this pole and this pole together so that when this pickup is on, this wire is activated and we go to our neck pickup tone control. When this pickup is on, we get the middle tone control, and when this is on, we have no tone control. That's how Strats were originally wired, and this was a three-way switch. So as you can see, standard 3-position Strat. Here's a standard 5-position Strat. It doesn't change the look at all. The difference is not cosmetic. It's skin deep. It's underneath. What it is the way they made these wafer switches from 1979 forward so you could have the 5 positions. They added an extra bit of metal here. So when you move down to position 2, these two linked up and these two linked up. And yes, you had 2 tone controls, but they kind of canceled each other out in a way. So it was whichever one was sending more high frequencies to ground, that was the currently active tone control. Then when you went in the middle position, it was like normal. Then you had middle bridge. So these connected, and in effect, this became your tone control for your bridge pickup. Now there's other types of wafer switches like this too that we can talk about here. So let's delete this, and let's bring in another one for guitar, because I'm sure there's multiple versions of this on here. So we'll go in here to the lever switch. This is the vintage style lever switch. Now we're going to go to a import Strat 5-position. This is the most common one that we usually see nowadays on like Squires and stuff. So now instead, your neck pickup's going to go, if we can just stop dragging the whole dang thing around. Damn it. So now your neck pickup's going to go here. Your middle pickup's going to go here. Drag it from that lead. So now your middle pickup is going to go here to this lug. If I can stop it from snapping. So we need to turn off a setting on here. Sticky points. Let's just remove the sticky points, and let's just drag this over here. We need to just stop the snapping and stuff. Auto edit, renumber, show rules, snap to, none. We're going to just plug this into the component right there. We got to bring it close. So there's our there's our middle wire, and our bridge wire goes here. And then we're going to kind of drag that off this way. So now we've got the neck, middle, and bridge wires here. And then we'll take this entire connection here, and we'll drag it over and close it in. So now we got that green wire right there linking these two middle red tabs together. And then we drag this over here, and then of course we have our volume or our tone controls, which are linked up like this. And this is how a modern Strat is typically wired. You have the switch. It's the same idea, same sort of thing. It's just a different layout. So you have your neck, middle, bridge, pickup, hot leads. Then you have these wired over here to these leads. I'm going to change my snapping to edit snap to components. So there we go. Yeah, snap to components. There we go. So now we have our 5-way switch in the modern way. And that's basically should give you the basics on how it works. But now let's go ahead and talk about some circuits on some actual guitars that exist that get more confusing. I'm going to try to teach you. Now we're going to take this switch out of the equation. Let's delete all that. Let's delete this. Let's copy this over here. And I think you know where we're going with this. So now we're going to take this simple thing here. There we go. We're going to drag it there. We're going to keep it connected. There we go. So we have those here. We're going to delete this tone control. And you know what? I'm going to just do this with a regular diagram. So right now we're going to talk about dual circuit guitars real quick and see if you can grasp it. So we'll go to Fender Jazzmaster wiring diagram. We're going to talk about the Jaguar and the Jazzmaster and their wiring diagrams. So we're going to go in here. We're going to open image a new tab. And here we are. I don't know if that's clear enough, so we might go with something higher resolution. Here's a good clear one. Open image in new tab. So on your typical Fender Jazzmaster setup here, we're going to use a Seymour Duncan diagram. We've omitted all the grounding bus to make it easier to see what the actual sound path is. So the whole system of a Jaguar or Jazzmaster revolves around this rhythm switch up here. That's what this whole circuit ties to, or really two circuits. Imagine it if there's a line in the middle. Over here we have your rhythm circuit. These are those rollers on the upper horn, and this down here is your lead circuit. That's the 3-way toggle and the 2 knobs you have on the treble side of the guitar. So the way the Jazzmaster works is you have this rhythm circuit that was engineered and wired very much specifically to sound much darker. So they try to do as many things as they could here with the circuit, and I'm not going to explain it, to go into a treble, more of a treble, remove as much of the treble as possible. This is done using a 1 megohm linear potentiometer over here. So this is done using this 1 megohm linear potentiometer for your volume and a 50K linear for your tone control. And it uses the input from the neck pickup, which is right here, and this is your output lug from the center of the volume pot, just like you regularly would see. And how does the neck pickup get into that circuit? Well, the neck pickup travels to this middle lug here, this double pull, double throw switch. When you slide it this way, these two contacts connect and these two contacts connect, giving an input and output to the circuit to connect. This is your output. Dang it. This part up here is your output. This part is your input. If you're over on the other side, this is your output and this is your input. So if we follow this wire, if we're in rhythm circuit mode, the neck pickup goes all the way into the switch, travels across the bridged contacts to that input, and then this input is sent to the tone control first, and then that tone control is fed into the input of the volume pot right there. Then the output from the volume pot, which is also affected by the grounding, this capacitor, and everything else, is sent to the output through here, which then sends it into this wire, which if we follow this wire all the way down, goes to the tip on the output jack on the guitar. Now we flipped into lead circuit mode. Say I'm going to go play a lead. Here's what happens. So our neck pickup is then instead fed through this wire here to this three-way switch, this Gibson style leaf switch, as we can see. So if I have the switch in the position that disconnects this leaf here, the neck pickup's disconnected. The neck pickup is disconnected and we're on the bridge position if we turn the toggle downward. If we flip it the other way, the neck pickup's connected. So how would we get sound, though, if apparently the path is going through here? Well, because the bridge pickup goes directly to the switch on the other side. And then this is our center lug here that goes out to our volume pot in the traditional position. And then that's fed into this 1 meg audio tone pot down here, which is then fed through an 0.3 microfarad capacitor to ground. And the volume pot in the Jazzmaster is not any different than the volume pot, except that's a 1 meg ohm linear, which gives it a slightly different taper, but probably due to the way Leo Fender designed the circuit, makes it work like you would intend. Outputs through this middle lug over here to the right side of the switch here, and then that feeds into your output all the way over to the output jack and sends the sound to the amplifier. So that is the basis of your two-circuit Fender Jazzmaster. You really have two separate circuits in this guitar that tailor the sound differently depending on the way it's been wired and the volume in the value of the potentiometers and the value of the caps and the value of the pots. So when you're flipped this way, you get a darker sound because it's all wired differently than what's on this side. And the whole idea of this, when Freddie Tavares brought this to Leo Fender in like 1957, was that you'd preset this circuit to whatever sound you were doing when you were playing rhythm and playing chords, and you'd preset this to whenever you were going to go take a solo. So then the only switch you had to focus around was this rhythm switch. A lot of guitar wiring has focused around making it more convenient for the player to actually make rapid-fire changes mid-set when playing live. And even back in the day, it used to matter in the studio, too, because you didn't quite have that, how should we put it? You didn't quite have the same options like now, where you could cut and paste multiple tracks of audio into the same track, or multiple tracks and EQ them and all that. Back then, you had to, even studio was basically a live performance put to tape. So you need to have your guitar able to perform quickly enough that if you had to change from neck to bridge, or you need to change from a softer sound to a tighter, more biting sound like the lead circuit on a Jazzmaster, you'd have that. Now we're going to go look at one more circuit here, and I'm sure you know which one it is. The Jaguar. Because the Jaguar grows off of that circuit massively. And we're going to make it less confusing, we're going to use the Seymour-Duncan diagram once again. So in the Jaguar, it's much the same thing. 1 meg ohm linear pot and a 50k ohm linear pot, except they do have the capacitor and some of the other stuff wired a little differently here. Again, same deal. This green wire goes to your output jack. That's your common middle lug for the output jack, and this one's for your neck position pickup, or the yellow wire. So when we flip the switch this way, and here it's kind of backwards. I think whoever did this with the plates flipped up and flipped over. So if you flip the switch this way and connect the contacts, let's just say this plate's upside down for demonstration purposes. So your input from the neck pickup gets fed into this white wire, which then gets fed into the 50k linear tone control. And then the tone control links it up to the 1 meg linear right over here. And then this 0.1 microfarad is just grounded off traditionally. You might think this would have a volume and tone effect, but I think this was really done by Leo Fender to keep the circuit dark. Because as we notice here, these Jaguar pickups are about the same size as a Strat pickup. They're a little bit taller, they're a little bit hotter wound, but they still need a little more help to get a little more treble bleed. And that's what this circuit, I believe, was designed to do, was bleed off more treble to make the Jaguar's neck pickup sound more warm when it's on the rhythm circuit. So That's what it does. Sends right over here to the volume pot, and then the volume pot either grounds off more of the circuit or lets more of it out through here, which then goes to your green wire, and then your green wire sends all the way down to the output jack into the amp. So there's your Jaguar rhythm circuit explained. Now the lead circuit is kind of the same thing. We have, as the Jazzmaster was, the same way. Yellow wire goes all the way over our yellow wire from our, our yellow wire from our neck pickup goes through here, and then instead it goes to this wire right here, the orange wire, which then feeds into this single pole, single throw switch here with two contacts. When the switch is in the up position, it puts these two together. When it's down, it disconnects them. That's the standard way a Jaguar is wired. So you put these two contacts together, you get neck pickup on. If not, you get it off. This is your common wire that feeds through to the strangle switch, which we'll get to that in a minute. Your bridge pickup over here, this white wire, gets sent over to this one, and this turns your bridge pickup on and off by linking or unlinking this common output wire here. Then the output wire is fed into this third switch, which then, if the circuit is broken, instead of when it's disconnected, instead it uses the making of this connection of these two dots here to bypass this capacitor. Because normally what will happen is you have the switch in the on position, which would be up, so this would actually be probably backwards. What you do is then it sends the signal from the pickup or pickups into this capacitor, and then this capacitor, what it does is it changes the frequencies allowed through the circuit to remove the lows from it. This is what we call a high pass filter, and hence why they call it the strangle switch, because what it does is it takes some of the lows and low mids out of the Jaguar's circuit before it hits the output line right here. But if you just put these together, you get the full circuit, and this capacitor is bypassed, which then sends to this blue wire right here, which, just like the lead circuit, to warm it up, it's fed through this tone control here, which has a 56K resistor linking up the two pins here on the tone control, and that's a way to bypass the tone control. And then that 56K resistor sends the middle lug is sent to the volume, to the input on the volume, so it can bypass this, or it can send it all the way through to this 0.1 microfarad capacitor, which is then grounded off. This is how they tailor the Jaguar's guitar sound. And this, again, unlike the Jazzmaster, where this is also linear, both of these are 1 meg audio pots. So what happens is then the signal gets sent through here, and it goes through this resistor, and then goes into the volume pot, which then grounds off on this side like a standard one. And then all of the mixed signal from all these controls down here on the lead circuit is sent through this yellow wire up into here, and then that links up to our green wire in lead mode, which then sends out to the output jack. And that's how you hear what you hear on a Fender Jaguar. It's really pretty amazing how far we can go with a circuit like this. Now, I'm not going to get into pickup switching options, and I'm not going to get into, in phase, out of phase, and series parallel until we get to another video, because I feel like this one's gone on long enough. I'll answer your questions in the comments as I can. Other than that, I feel like this really was productive, and it might have been helpful. Again, the program I used for most of the demoing here is DIY Layout Creator. So this is CreepingNet signing out, and I'll see you in the next video.